Good afternoon. Today is May 7th, 2025. We're here in Nashville, Tennessee at AIST Tech 2025, and it's my privilege and honor to be here to interview Bill Emling. Bill is a distinguished member of the AIST. I'm Chad Donovan. I work for SMS Group. Bill was a mentor to me in the industry and was my direct boss for several years of my career. This recording is a part of AIME's Oral History Capture Program. So, Bill, we'll start off, and maybe we'll go over your childhood, schooling, and what really got you interested in engineering. So maybe if you could start off by telling us, well, where you grew up, what your parents did for a living, that sort of stuff.
Thanks, Chad. Yeah, I lived the first 13 years of my life in Erie, Pennsylvania, and then I moved to upstate New York to a town called Fairport, which is a suburb of Rochester, New York. My dad worked as a salesman for Kraft Foods, and he actually was promoted when I was 13 to become an account manager for this little grocery chain called Wegmans, which is now one of the biggest ones in the country. My mother was a homemaker, and I have a sister that's a year and a half younger than me. What I really recall the most about what influenced me to become an engineer was in 1965. I was 8 years old, and we went to the New York World's Fair. And that was the second year of the World's Fair. There was quite a bit of information and displays about industry. And there were things, future concepts, future things that were presented, like a speakerphone and video phones and things like that. So I was fascinated with that. Also, I was deeply following the Gemini and the Apollo programs from NASA, and the amount of technology and the science that was there was really kind of intriguing. My uncle, by the way, my father's brother, my Uncle Bob, was an engineer. He worked for General Electric, the locomotive division in Erie. And he had a really good job, and he was a great teacher. He took me when I was entering high school on a tour of his factory, and I kind of was snake bit with the whole idea of design and engineering. So that really caused me to be most interested in engineering.
So you know, what drove you to choose the school that you ended up going to, and maybe tell us a little bit about how that decision impacted your life and how that all went down.
Yeah, it had a major influence in my life. I was always strong in math and science, and knew pretty much that I wanted to be an engineer. And my Uncle Bob, by the way, had gone to CASE, Institute of Technology in Cleveland. So I applied there. I also applied to Cornell and the University of Buffalo, and I was accepted at all three schools. But I really liked CASE because of the size. It was a smaller school with class sizes. And once you got into your major, maybe 10 or 15 people. And they gave me a really nice financial award package. So it made the choice or the decision a lot easier.
Maybe tell us a little bit more about the program at CASE. Was it material science? Was it metallurgy? What really got you down that path?
I enrolled, and I declared myself a mechanical engineering major in my first semester, but you didn't really have to commit until you were a sophomore with your what track you were going to follow. And in my second semester, I took a course in material science, and I really loved it because it had a lot more chemistry to it and less physics, and it seemed like that was a natural fit for me. And one of the professors was working with NASA, and he had moon rocks, which were at the time like, whoa, something out of this world, literally. And they also talked about their graduates had no problem finding jobs, and the curriculum looked to be really up my alley. So I switched after my second semester to metallurgy and material science.
Was there any professors specifically that influenced you while you were there?
Yeah, I had a kind of a mentoring professor, Dr. Ebert. His specialty was materials and sports, and he had a whole lot of these sporting goods companies like Wilson and McGregor and whatever who funded their research. And actually, my senior project when I was a senior and undergraduate was instrumenting golf clubs with strain gauges to measure the force and the torque and so forth imparted on the metal shaft. And what I chose to do was to instrument it. The same club I gave to one of the seniors in the university that was on the golf team, who was a good friend of mine. So I got to see the impact of a really good golfer, and then I, being the poor golfer, as you know, was able to look at the difference between the two. And so it was a kind of fun project, and I enjoyed it. During my time in college, I was in student government. I was the president of the Undergraduate Metallurgy Society, played intramural sports and so forth. But the biggest impact was I was a member of Sigma Alpha Epsilon fraternity. I really honed my leadership skills at that young age because I was a secretary, vice president. I was a trainer for the new recruits. I was a special events coordinator on campus. We did blood drives and things like that. So I really had a chance to do some cool things in terms of working with people. Between my junior and senior year, I had an internship at Republic Steel in Warren, where I worked in the melt shop. And I really kind of caught the bug of steelmaking. When it came time for graduation and looking for a job, I graduated in 1979, and it was a really good year. We were inundated with recruiters from various companies, and I took job interviews with automotive companies, with electric power companies, a lot of different industries, but nothing really compared to the excitement of the steel industry that I experienced with my internship. So,
and that internship was between your junior
and senior year, yeah. I took quite a few interviews and had a lot of job offers, a lot of opportunities, but I chose National Steel in Granite City, Illinois, which now is part of U.S. Steel. And I was supposed to be the hot strip mill metallurgist, or the assistant hot strip mill metallurgist. Well, by the time I arrived in St. Louis area, that job had already been filled, even though it was promised to me. And there were 2 or 3 individuals who were off for medical reasons. So they made me a turn foreman and working shift work. And it was from the coke plant to the blast furnace to the BOF to the blooming mill, This is before casting, and the scarfing dock. And I had probably 35 or 40 hourly employees that I had to be the supervisor for. It was rotating shifts, and didn't have weekends off, didn't have holidays off. And I almost quit because I had been built up in college that, hey, you're going to be the leaders of tomorrow. And here I am working graveyard shift. I couldn't see my girlfriend, who I eventually married. The days I had off, she was working. The days she had off, I was working. And so it was very difficult, but I kind of, in my mind, thought, let me persevere. Let's keep at it. And eventually I got on day turn, and then I got involved in the startup of the #1 caster at Granite City. So I kind of drew the analogy of going in the military for a 2 or 3 year period that is a little tough, but if you make it through, you'll be better off for it. And quite honestly, I didn't care for it very much when I was there, but it was one of the best experiences I've ever had, because I had a chance to learn how to deal with people who were much older than me, much more experienced than me, and just learned a lot about interpersonal skills. There were rough times, but there were also great times. And I got to learn the steel industry kind of from the ground up.
Yeah, so that first major project, that new caster,
Yeah.
I mean, that's pretty cool.
Yeah, it was.
So, I mean, as a young engineer, tell us a little bit more about that.
Yeah, actually, what they did, National Steel hired 3 metallurgists, and they combined us with another person, and we worked rotating shifts, which was, again, a little downer, but it was really inspiring because I could be there during the last stage of the construction and the entire commissioning. I learned a lot. I learned about how the caster works, and kind of started to get an innate sense of what was good and what was bad. I did have one terrible experience that when I was on my honeymoon, there were 2 people that were on my crew that died. There was a terrible accident where ladle slag was sucked down into the mold during the operation, and they had an explosion, and that had a profound effect on me. But so I was determined to learn about safety as well as the operation. So it was difficult to transition from being a hotshot on campus and, supposedly going to solve all the world's problems, and then you went right to working on shifts. But it really helped refine my people skills, which came in really handy later.
When did you leave St. Louis, and what kind of caused you to move on?
What happened was, after the commissioning of the new caster, I was assigned to be the blast furnace metallurgist. And it sounds exciting and dynamic, but it really was not a very dynamic job, because what I had to do was to sit in an office in the basement of the superintendent's office, and I had to get in at 6 o'clock in the morning and key punch in chemistry data from the slag and the metal, so that we could run burden calculations. And I had to have a set of computer runs on the superintendent's desk by 7 a.m. every day. And they discouraged me from going out onto the floor to talk to the people. They wanted me at their beck and call to do these kinds of things. So I really wanted to do more development work, because I got my feet wet with a startup of a caster, and I had been responsible for a hot metal desulfurization startup. And so I decided that I was going to leave. I was contacted by J&L Steel in Pittsburgh for a job as a research engineer in the steelmaking division. So after 2.5 years, I left that first job.
Where did you end up after leaving St. Louis?
Yeah, so after 2.5 years, I left, and I was contacted by J&L Steel, Jones and Laughlin Steel in Pittsburgh, Pennsylvania, at the Graham Research Laboratory. And they had a job as a research engineer in steelmaking. So that was really exciting, and my wife wasn't real happy with her job in St. Louis, so it made it for an easier decision. So we left, and I worked in the BOF, the basic oxygen furnace area, and ladle metallurgy. And at the time, J&L had announced that they were going to build 2 new casters and commission them in 2 years later. So I wanted to get involved with that, and I kind of received a commitment that I would. So I left National Steel. I didn't really have any mentors at National Steel, but I remembered that because I didn't want any employee that I ever managed to be handled the way I was being handled. Not to say any names negatively, but it didn't work out. But I learned a lot. So what I did is I worked in the BOF ladle metallurgy area at a number of steel shops at J&L, but most notably at the Indiana Harbor Works in East Chicago. I worked on BOF bottom stirring, putting tweers in the bottom of a furnace and seeing what that did to the metallurgical properties. So I worked for a little over 2 years in that capacity, and suddenly they decided to form a new division of the research department on continuous casting. So I joined that group, and I knew that living in Pittsburgh, supporting a startup was going to be a 7-day-a-week job. So I asked my supervisors if I could be moved temporarily to East Chicago. And that was done. I was there from 1983 to actually 1986. So it was longer than I originally anticipated. But I did get involved in 2 more startups, working as the corporate research representative for J&L. And it was a really nice job. After 3 years, I was transferred to Cleveland because in the meantime, Republic Steel and J&L Steel merged to form LTV Steel, and their headquarters were moved from Pittsburgh to Cleveland. So I was transferred to Cleveland at the very end of 1986. So I worked there in the research center in Independence, Ohio, for 7 or 8 years. Eventually, I became the corporate manager of continuous casting research. It was an interesting experience. I wrote a lot of technical papers. I hired a lot of young engineers, and one of the things I wanted to mention was I knew I eventually wanted to get into operations and not be totally technical. The research we were doing was very applied, where we were in the plant all the time. But what I did was I did have a few mentors in that role. I had Bob Blasi, my first supervisor in steelmaking, then Pierre Doby in continuous casting. But we worked at the Cleveland facility under Bob McCormick. He was the superintendent, and Len Nelson was the assistant plant manager for Cleveland. And I spent a lot of time really helping them on a lot of operational improvements. And at one point, I volunteered to work weekend duty to basically run the Cleveland Works operation on weekends, to be part of the rotation. I think there's 4 or 5 people, so every 4 or 5 weeks, I would work a weekend and be responsible for the entire Cleveland Works. That gave me some real nice experiences. I learned a lot about hot rolling and cold rolling and some of the other areas. But I started to gain more experience and credibility. So after about 8 or 9 years, there was an opportunity to move to operations at the direct hot charge complex. We had built another new caster on the west side of the Cleveland plant, and I took on 3 different areas or departments. I was in charge of refractories, I was in charge of the chem lab, and I was in charge of the ladle furnace during the week. And then, of course, on weekends, I was part of the rotation where I ran the caster. So that was a really interesting experience. And eventually I ended up taking over the operating technology department for all of Cleveland Works. So I had engineers working in multiple different departments that reported to me in addition to their own particular department manager. I was, at one point, I was the youngest department manager in all of LTV, and I really thought I'd be there for the rest of my career. And little did I know that things were going to change.
So maybe you can tell us a little bit about that. What happened?
Yeah.
You know, I mean, you know, that's an important historical thing, right?
Yeah, I think so. Actually, before that, I wanted to mention that I transitioned from research to operations. When you're in research, you run trials in the plant, and you work with the hourly employees, and they become your friends. You're in the pulpit, you're out on the floor talking to them, and sometimes bringing in donuts to improve the relationship. So 1 minute I am their best friend, the next minute I'm their adversary, because it was a highly unionized environment, and LTV had just announced the formation of a company called Trico, which was a Japanese company, a British company, and LTV. They opened a plant in Decatur, Alabama, which is now Nucor Decatur. It was a non-union plant, and the head of the local in the union was in my department. So it became a little bit difficult. That was exactly the same time that they announced Trico. So I had some rough periods of time adjusting to operations, but I really, really enjoyed it. I had probably about 65 employees. Everything was going well. The LTV decided to send me to a business school development. I was invited by Case Western Reserve, my alma mater, to be part of the Weatherhead School Fellows Program, which was more or less like an accelerated MBA, but it was 50% academic coursework, case studies, and 50% introspective, looking at who you are, what you think you're good at, what you want to do with your life. And I came to the realization that I really wanted to work with multiple companies on multiple technical challenges. And at the time, LTV was going through very difficult financial times. And there were a lot of bankruptcies in the industry. There were 2 at LTV during my 18 years that I was there. But after working as a steel producer for 21 years, and actually I was the head of the mentoring program at LTV for young engineers. So I was a little conflicted because I'm encouraging youngsters to stay with the company and enrich themselves and grow. But I had to take care of myself because it looked like there was Chapter 7 ahead. And sure enough, that's what happened 2 years later. So I decided not only was I going to look for another job, but I was wanting to deal with a lot of other people, and I decided to become a supplier. So I joined Acutis Gladwin, which was eventually 2 years later purchased by the SMS Group. I became the Vice President of Maintenance Technology. So the first couple of years I was there, I worked on technical challenges that the various steel companies had. And it was pretty rewarding. And the transition from working as a steel producer to working as a supplier was kind of unique. There aren't a lot of people that do that. Sometimes they go the other way. But I had, during my previous 20-some years, been involved with the Iron and Steel Society. ISS and AISE were the 2 predecessors of AIST in writing technical papers and being chairman of different committees and involved in quite a bit of activity. So I did have some credibility when I went in to see customers, that they knew who I was, they respected me for what I did, and they listened to me. So it was interesting that I approached the customers as if I was one of them, not necessarily as a sales guy. And so that was a interesting transition, but I was very happy that it worked out the way it did.
Well, I'd like to ask you, like, some specific contributions to the industry or different technical challenges that you may have come across in your career, and maybe a couple things that you would like to talk about related to those.
Sure. Yeah, I had, the toughest technical challenge as a producer was making the automotive exposed IF grades, ultra low carbon interstitial free steels, because they were very sensitive to any intervention by the operators. And they were also very much prone to mechanical damage because they're very soft steels. So the slabs and the coils ultimately ended up being bruised and scraped. And so there was an awful lot of problem solving that myself and my group had to get into at LTV. So that was probably the biggest technical challenge. As far as non-technical challenge, I had transitions from working turns my first job to then going from research to operations, and then going from operations to sales as a supplier. And I had other transitions, and adjusting to those transitions sometimes was relatively easy, but sometimes it was hard because I was replacing somebody who was no longer there, and I didn't have any ability to learn from anyone. So some of my contributions to the industry, when I was at LTV, I was exposed to different technologies internationally for preventing breakouts. And I formed a small committee of a computer person, an electrical person, a mechanical person, and myself. And we decided to design our own breakout prevention system. And I had to convince the operators to actually drill holes into their mold coppers. And they thought I was crazy. And I know I had to convince them that it was going to be safe. And some people believed me, some didn't. But we eventually did, and we stud welded Constantin rods to the copper to create a type T thermocouple base, and we just guessed at the location of the thermocouples based upon our understanding of the solidification and the casting speeds, and we connected the I/O to a little IBM. Well, I think it was a 186 computer. It was pretty crude, but it was very, very successful because in 1984 there were 14 sticker type breakouts, and in the first 12 months that we put the system in, there were 0 sticker breakouts, and for that that probably resulted in about $10 million, maybe $12 million worth of savings in uptime and repair materials and so forth. So I wrote a paper about that, and we eventually, when I transferred to Cleveland, I helped the people in Cleveland in the same way. And I became known as somebody that could help with breakout detection. And that led to quite a bit of notoriety within the ISS and amongst LTV people. Eventually, when I went to Acutis Gladwin, which became SMS, our group got involved with upgrading the fixation of the thermocouples, adding a lot more thermocouples, upgrading the system to a more robust computer, and eventually fiber optics to replace the thermocouples. It was kind of interesting that we developed a system in 1984 that I went back. I hadn't been back in that plant until 2001. And so it was like 17 years. I went to Indiana Harbor Works, and they still had the same system in place after 17 years. So that made me feel incredibly proud. But with our new company, we were able to upgrade them and others and really develop the technology. And that was a major contribution in the world of casting, I think, that I was involved with, not as myself, but as a leader of other people. I'm also very proud that my group that I had at SMS was involved in the startup, design, commissioning, and so forth of several electric arc furnaces. The United States is now 71% electric arc furnace melting. When I started with SMS, it probably was about 50%. So SMS became a real leader in the electric arc furnace field. We installed some of the most productive facilities in in North America, and it contributed to the sustainability and the lower carbon footprint of the North American steel producers. I'm also proud of the work I did on the AIST Foundation. I spent 7 years as a foundation trustee, and during that time, I was responsible for leading the Young Professors program, which gave significant amount of money to college professors that weren't yet tenured to conduct steelmaking research and develop steelmaking curricula. And that's led directly to students joining the steel industry. The other big thing I was involved with was the development of the scholarship internship program. And I just heard this morning that there were 49 students last year that took advantage of this. It's a combination of, I think it's a $7,500 scholarship and a paid internship. And students can apply for it 2 or 3 years in succession. And that's led to some tremendous opportunities for some young people to join in the industry.
You've gone through all these transitions, different, being from the operation side, producer side, moving over as a supplier. What about your family? Going through all this.
Yeah.
I mean,
Yeah.
what were they going through?
Yeah, that was something that was really important. I want to dwell on that. So I can tell you about my family now. My wife, Jean, and I were married when I was about ready to leave the first job in St. Louis. And we moved to Pittsburgh. We had a kid. We had my son, Brian. And then I got transferred to Indiana Harbor, and we had Patrick. And then I got transferred to Cleveland, and we had my daughter, Jenny. So we decided we were going to stay in one location after that. And we remained in Cleveland for 13 years. But when it came time to transition from being a steel producer at LTV to a supplier, we had to move to Pittsburgh. And that was very difficult for the family. It was difficult for me because I was transitioning to a new role, and I was reporting to the CEO. It was difficult for my wife because she had to basically manage the whole thing. And I had 2 boys. The 2 boys were both in high school, so we had to uproot them during the high school years. And my daughter was in middle school. And we got through that transition together. We understood that we couldn't remain in Cleveland because the company wasn't going to be around, and my job was pretty much going to go away. And we had 2 boys approaching in college. If we wanted to help pay for the university, we needed to sustain the family income. So we did a lot of soul searching and a lot of talking, but we got through it all together as a family, and we were much better for it now.
So, Bill, I'd like to talk to you about the different membership societies that you've been involved in your career, and maybe you could, tell us about some of the history that you've had with them, and
Sure.
where we're at today.
Yeah. I first heard about AIME and the Iron and Steel Society in particular in 1981 when I moved to Pittsburgh. And my supervisor, Bob Blassie, strongly encouraged me to join the steelmaking group, which had 3 or 4 meetings per year. Also, the AISI had operating committee meetings. But the first experience I had speaking in public was in 1982 at the Detroit Off the Record meeting for the ISS. And I gave a talk on BOF steelmaking. It went well. I joined the Midwest local section when I was transferred to Indiana Harbor. And then later, when I was transferred back to Cleveland, I was on the board of the Cleveland local section. But I got involved with, heavily involved with the ISS steelmaking group. Eventually, I became the chairman of the steelmaking division. And that led to me having a seat on the board of directors of the Iron and Steel Society. I also joined AISE along that timeline and went to several meetings of that organization. But when I was involved as a board member for ISS, it just happened to correspond to the time when AISE and ISS merged. And after 2 or 3 years on the ISS board of directors, I was asked to serve on the quote-unquote super board, which was a large group of people that were from the AISE board and the ISS board. So we came together, met each other, and we actually worked on the name AIST, the bylaw creation of the different divisions and so forth. I met a lot of really good people, and there was a real commitment to work together to make this merger work. Oftentimes there's animosity from one party to the next, that this person's being promoted and that person isn't, but it wasn't like that. We chose Ron Ashburn as the leader, and Ron did a great job of bringing us all together, and it was a tremendous experience. After that was over, I worked with the Continuous Caster Technical Committee. I was the first ever chairman of that committee, and we ended up creating this practical training seminar that you, Chad, and I are both involved with. We were involved, or I was involved for 15, 16 years, and it was a great experience. I later spent 7 years on the foundation board as a trustee, as I mentioned before, and now I'm a member of the Pittsburgh local section, and I'm a member of 3 technical committees still. So I plan to keep active, even though I'm semi-retired right now. I want to continue to give back to AIST.
Well, maybe tell us, you have an interesting family twist with AIST as well.
Yeah.
So, I mean.
Yeah, my daughter, Jennifer, is a technical editor for AIST. She works on the magazine, among other things. She's in charge of the directory, the Black Book. So she has a chance to talk to steel producers and suppliers to get their information and assemble that. And she's in charge of the AIS Tech proceedings. So that's not just collecting the papers and putting them in a book, it's editing the papers and making them all the same format. So it's interesting, this year I gave a technical paper and I had to have my daughter edit the technical paper, which was completely the opposite of what it was in high school when I was editing her paper. So that's kind of interesting.
You know, one of the reasons that I'm here is you helped build me up with AIST.
Mm-hmm.
Can you talk a little bit about how many people you've really, I think, helped open their careers as well, using these member societies?
Yeah, sure. I guess one anecdotal story I want to tell is about when I was at SMS as a vice president, and suddenly there was a situation in Oil City, Pennsylvania that occurred. Oil City was the largest service plant that SMS had at the time, and the plant manager had bone cancer, and he died very suddenly. And his assistant was, who was in line to take his place, had previously announced and accepted another job and was leaving the company. So there was a void in leadership, and I was asked by our CEO to go there, learn the job, grow the business, and help out however I could. So suddenly I showed up sight unseen in 2003 and had to really learn the business. And I had to commute 89 miles each way in the morning and in the evening, which made for very long days. But I didn't want to move my kids again. My daughter was the editor of the high school paper, and I didn't really want to move her. So I chose to commute. But I had an opportunity to really analyze the business, to look at the people that were involved, and kind of work on the development of their skills. And I was able to take certain people that really impressed me and put them in leadership positions and get them involved in AIST from a technical training standpoint, from learning customers a little bit better and closer. And one individual in particular was you. Chad was a probably mid-20s young engineer that was working on the plating operation and had taken care of a considerable quality problem. And even though he was maybe 20 years younger than his colleagues, he had the respect of the people in the plant. And so I ended up working with Chad with a couple of particular customers. I went on your first airplane ride, I think, to Arkansas, and we established Chad as a key account manager for Nucor Hickman, who became our largest customer, and that was something that was really interesting because I saw something in you that could really be developed, and Chad seized the opportunity, and so eventually he was promoted and became the assistant plant manager at a relatively young age. And when I was promoted to move back to Pittsburgh to become the VP of Steelmaking and Casting, I chose Chad as my successor, which was a little controversial, but it was definitely the right decision because the progress that we made in the 3.5 years that I was there paled in comparison to the progress that Chad made after he succeeded me. So I remain very proud of that situation.
Thank you too.
So, but over the years, because in my first job, I really didn't have a mentor. I had great mentors afterwards, but I resolved to do whatever I could to work with the young people that I brought into the industry. So I gladly joined the foundation. I was responsible for a lot of people who joined the industry from academia. As vice president of SMS, Steelmaking and Casting, or the metallurgy division, I probably hired 20 people over the years. Many of them have moved on to be leaders in their own capacity, CEOs. I'm very proud of that. When I was in operations, I had turn foremen. One is Barry Schneider, who's Chief Operating Officer of Steel Dynamics. Another is Dave Samosky, who's Chief Operating Officer of Nucor. And so along the way, we've had some good success, and I've always enjoyed helping the younger people. And that was something that I naturally fell into, and I continue to do to this day.
So, Bill, maybe you could talk about some of the honors and awards. You've been in the industry all these years. What's been bestowed upon you?
Yeah, I'm not the kind of person that likes to brag. I appreciate the awards. They mean very much to me, but they really represent the accomplishments of other people who I worked with as well as myself. Early in my career, as I mentioned before, I've authored a lot of technical papers on continuous casting and steelmaking. I won 3 Best Paper Awards from ISS and also AIME in the late 80s, early 90s. I won Achievement Awards at LTV for the improvements that I made in breakout prevention and in quality improvement and operational improvements. I was awarded a citation by the AIST president in 2018 to recognize the accomplishments I gave to the foundation when I was a trustee. In 2021, I got the Thaddeus or Tadeu Senzimir Medal, and I was very happy about that. In 2023, I think the award that meant the most to me was becoming a distinguished member and fellow of AIST. And then last year, I was awarded the Benjamin Fairless Award. So along the way, as I said, these things are great. I'm very honored and humbled, but I don't really want to brag about it because it is not my personal accomplishment. It's myself and the people that I worked with as a group.
You've always been a guider of these younger leaders or younger people. What advice would you have for today? What advice would you be able to give young leaders or engineers that are coming into this industry?
Well, take advantage of every opportunity you can. The AIST presents a great opportunity. Other organizations that you can join also have those opportunities, but the AIST in particular has the technical committees that meet 3 times per year. Attending those, meeting people, volunteering to maybe even be a leader. There are a number of offices that one can hold along the way. I think the technical training seminars that are offered and even the local sections meetings, that they permit or allow the engineers the opportunity to learn the latest technologies, but more importantly, to interface with other steel makers, both suppliers and producers, and people from academia. An opportunity to meet people, establish contacts. The steel industry is really like a fraternity. It's a small family. Believe it or not, it's over 100 million tons per year is produced and consumed in the United States. But the industry is very close-knit, and there aren't a lot of secrets that are held back. So in many cases in my career, I had some technical challenges. I pick up the phone and call somebody who I met through ISS or AISE or AIST. So I would encourage young engineers to get involved. Talk to your supervisor, tell them you really want to do that. You become a more effective employee for that company that you work for.
Bill, I'd like to ask you about the major milestones that you've seen in this industry. You've been in the industry now several years, and maybe talk a little bit about what youth believes the biggest changes.
I'm sure there's quite a few things that have had impact, but I think the biggest impact in my mind is the creation and the proliferation of the mini mill. The melting of steel during my time in electric arc furnaces, as opposed to oxygen steel making, really developed tremendously with the ultra high power furnaces and the introduction of chemical energy, bringing tap to tap times down in some cases to 30 minutes or less, which is approaching a BOF type productivity. And that coupled with thin slab casting, which was first developed at Nucor Crawfordsville in 1989. SMS was the inventor and the partner with Nucor. That proved that you could cast and hot roll in a continuous operation, which saved a tremendous amount of money. And it brought the mini mills to the point where they can compete head to head with the integrated producers for significantly lower cost. And that's now led in recent years to endless rolling for both flat and long products, and achievement of quality and productivity values that would never even been possible to dream about back before the late 1980s.
Are you able to sum up your career in 2 or 3 words? Or, I mean, is there, I know it's hard, but maybe, or at least in a statement.
So I would say challenging, but inspiring. Being able to take on and resolve very difficult technical and non-technical problems is very rewarding, but it's also very inspiring that it brings you back the next day. So no 2 days in my career were ever the same. And the opportunity to work on leading edge technology has been really exciting and very rewarding.
So, Bill, what advice would you have for today's young leaders, in the industry?
Sure. I think simply work hard, play hard, enjoy yourself, but cherish family time. And that about sums it up.
Okay, Bill. Thanks for taking this time with me, and I really enjoyed the conversation, and I really enjoyed yourself as a mentor for me, and all you've done for so many of the people that worked with you and for you to help grow their careers in this wonderful industry.
Well, thank you, Chad, for your time. I had to choose who I wanted to have interview me, and it was pretty obvious who I wanted to have.
Well, thanks.
Easy choice to make.
Thanks.